Everyone, and welcome to episode 7 of the series on computers, on Python programming, and on data science. In this video, we're going to do the third module of Yandex Python programming tutorial. So if we click on this current course here, we are now on operations with tables. So let's start with the first one. You will learn how to manage data in tables and acquire new tools for analysis, sorting data in tables, adding new columns, and identifying particular strings. Let's go. Okay, we're going to be doing a lot of printing in the future, so it'd be wise to expand our arsenal of printing methods. Do you remember that the print function always ends in a new line? This can be avoided by specifying the end key. By doing this, we will indicate that printing shouldn't end with a new line, as it does by default, but with something else instead, such as an empty string. In order to separate the words with a space, add a space after the first word or before the second. The end is a named argument. In order to use it, you must indicate both its name and its value. Named arguments are created for functions that already have numerous individual arguments and options. These functions can be confusing if they haven't already been given names. Please take note that there are no spaces before or after the equal symbol for named arguments. Okay, so column names that form the header of this table are stored in the header list. Print the header like this: name, Emoji Express, Mill, Instagram Mill, Twitter Mill. In order to this, use a loop and a print function without entering a new line. Okay, so we have a list here, right? So we can go back to the loop unit and just use the for, I guess we could do for string in header. This is going to iterate through the list. It's going to give us name, then Emoji Express Mill, then Instagram Mill, then so on. So we want to print the, let's see. First we want to print a pipe character, a vertical line, before we go on the loop. That's because, well, I guess we don't need to do that. We can do it inside the loop because we can print that first. So we'll print the pipe character, and then what else do we want? We want no new line. We just want it to be on the same line, so we do end equals nothing, and then we can do plus the string in the list, right? So what this is going to do is it's going to print a pipe character, then a space, and then the new string, and then not go to the new line. Then it's going to go up to the next line. So we do need a space after this string as well. Okay, so we do pipe character, then we'll have each element in the list. So we'll just say name, then we'll have space, then it'll go back up to the loop again and change to Emoji Express, print the pipe character, then the space, and then the Emoji Express Mill, then a space, and then it'll go back in the loop again and do Instagram Mill, do a pipe character. So when we get all the way through the list, we're not going to have this ending piping character, so we need to put that in at the end as well to end the line, I guess. So we can do print pipe. So let's see if that's what they're looking for. I'll run this code just so you can see what it looks like. Okay, hopefully that's what they're looking for. We did one thing outside of the loop just because we need that last pipe character. Correct. All right. All right, methods in Python. Let's try to sort the emojis by quantity in order to understand what the situation is like on various platforms. In order to do this, we will have to sort the elements of the chosen column. First, let's learn how to sort regular lists of numbers. Python has a sort function that will allow you to do the following. So they give you a list, say, of 2.26, and you notice the second one is 19.1, which is greater than 2.26. But you get to this, and this is bigger, and this is bigger, but then 15.2 should have been, if this was a sorted list, it should have been right after the 2.26, right? And the same with 22.7, that's less than 25.6. So this is not in any order. This is almost like a random list of numbers. So then they sort it, and then now we have it in order. You can see 0.33 got moved to the first because that's the smallest number, then 1.74, 2.26, and it's just getting increasingly bigger. So that's what sorting is going to do, is put it in the right order. Please pay close attention to the special method for calling the sort function. The function is written after the list with a dot in between. This method is called the dot notation. The sort function is associated with the data type list and generally works on this specific type of variable. Functions like this are called methods. We have encountered a method before. The format function is a method that is associated with the string data type. Please remember that every method is called using the dot notation. Okay, so a list of strings can also be sorted using the sort method. This method arranges them in alphabetical order. Arrange the names of all emojis in alphabetical order and print the list with each element on a new line. Okay, so we need to first sort the list, which we do by doing emoji underscore names dot sort, just like they had up here. We'll scroll back up to see if they did dot sort. Okay, and then they want us to print the list with each element on a new line, so we need to do another loop for, let's see if they have a special name for it. Arrange the names. So name of emoji in emoji names. Let's shorten this. Let's just do for name in emoji names. This is going to iterate through each element in the list. So first we get grinning, then we get beaming, then we get raffle, and so on. We're going to print the name. I think that's all at once. Let's check it out. So beaming comes before fire, which comes before G. So BFG, that's in order. H, 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 K, K, L, R, S. So that looks right. So let's check that. Correct. Let's move on to the next one. The Boolean values true and false of the sort method. So yeah, if it hasn't said that before, a Boolean can either be true or false. That's another type of data type. By default, the sort method always arranges lists in ascending order. If we choose to sort in descending order instead, we'll have to point it out by using the named argument reverse. So you can see we have the same list that we had in the last section, last problem we just did like a second ago, but instead they're putting reverse true here, and so now instead 233 is first and 0.0333 is at the end. The reverse argument should be set to true. This value is a new data type called bool or Boolean, which is named after George Boole, the creator of propositional calculus that today is referred to as Boolean algebra. He invented writing logical statements with the use of symbols. The two values are possible for Boolean data, true or false. The expression reverse equals true in Python means sorting should be done in the reverse order. If we don't write this, Python will assume reverse equals false by default, meaning that sorting should not be done in reverse. True and false are capitalized in Python to differentiate them from variables and argument names. Okay? So print a list of quantities of posts on Twitter in descending order, high to low. Print each individual value on a separate line. So it's the exact same code we did last time, but this time it's going to be in reverse. So we do twitter.sort, and we do reverse equals true. Okay? And then now we're going to do the same thing. So for number, this is quantities, I guess. For quantity in Twitter, we're going to print the quantity, and that should just put them all on their own new line. See what that looks like. Perfect, that's in descending order. So let's check it. Perfect. All right, next task. Sorting by column. Sorry, that's my buddy texting me. Okay, Remember that Python stores tables as lists of lists. If you need to sort a table by a specific column, designate it with the named argument key. Let's try to rearrange the rows of the table so that the elements of the column emoji express mil are in descending order. Ascending order. Okay, so they give us grinning, beaming, raffle. And we're going to sort key equals lambda row 1. This is interesting notation I haven't seen before. Okay. Python doesn't process our list of lists as a table. It sees a list of strings. As far as Python is concerned, there are no columns in this table. In order to sort the table by contents of the column with index 1, we need to make it clear first. Let's assume that the sequence that is to be sorted are the elements with index 1 in every row. This explanation uses a lambda, a short unnamed function. The function receives successive rows as input and returns a column of elements with index 1 from each row. In our case, this is written as row 1. We've chosen the name row for successive rows for clarity, but you can call it anything you'd like. You'll learn to create full-fledged functions in the following chapter, but for now a simple lambda is sufficient for sorting. Named arguments can be combined. As an example, let's sort the data in the column emoji express mil in descending order, using key and reverse simultaneously. So they're giving you the same list as last time. They're putting the key equal to the row. So let me explain what this key equals lambda row is actually doing. Okay, so what it's going to do is it's going to sort this list by the row, right? So this is a list of lists, right? We want to sort it by the by individual rows, right? And on each individual row, we're going to grab the first element of that row. That's what this colon is doing. So what the sort function is going to do is it's going to look at each individual element, because that's what you're specifying here, each individual list, and then it's going to look after the colon. It's going to look at argument 1. So this is 0 and this is 1. So it's going to look at this first section for each list and sort the list of lists by that. And it's going to set it reverse equals true. So it means it's going to go in descending order. Okay, so when they print, you can see the first one they have here is 2270. It's weird because this is not wide enough to actually see what the output is, but it's sorting by this and then this and then this. Yeah, why is 834? It's confusing because it's not on the same row. But let's see. Sort the table by the column Instagram mil in descending order, and then print it visually in a visually clear format. See the pre-code. Make a note of which emojis are the most popular on this platform. Okay, so we're going to do data.sort. And they want us to specify the key, which is going to be equal to the emoji express. We do this lambda, what is it, row? Let's go back to what they did. Key equals lambda row colon, and then we want to do it by emoji express. Let's see what row emoji express is. Dang, the scroll wheel sucks. Okay, so 0 is name. They skipped emoji, and emoji express is 1. So we're going to sort by row 1. Okay, and then descending order, so we need reverse equals true. And then they print everything here, so that should be taken care of us for already. Let's see what it looks like. So here's what I was talking about before. It's sorting by the here, so 233, then 118, so it's getting smaller and smaller and smaller, right? And so again, what this is doing is key equals lambda row, right? So when it's sorting, it's going to look at each individual one of these lists. And what's it going to look at in these lists? That's what this colon is saying. It's going to look at row, or it's going to look at the element 1, right? So this is 0, and it's recycle. So if we had set row equal to 0 here, it would sort alphabetically by the emoji name. But since we specified row 1, it's going to look at the emoji express line and sort by that. We could have specified 2, and it would have sorted by Instagram mil. Or we could have done 3, and it would have sorted by Twitter mil. Okay? So let's check if that's right. sort the source list. Interesting. Sort the table by column, Instagram. Oh, Instagram mail. My bad. I did Emoji Express. You guys see that? So it should be 2 here. In descending order. Okay? Perfect. Next. Sort the table by column Twitter mill in descending order and print it in a visually clear format. Make note of which emojis are the most popular on this platform, which artifact or peculiar detail stands out. Okay, so now we do the same thing. We do data.sort, and we're going to do the lambda, or I guess it's a key equals lambda row, colon, row, and this time it's Twitter, which is 0, 1, 2, 3, row 3, and it wants it in descending order, so reverse equals true again. Okay, and then it should print it for us automatically. Okay, so we see tears of joy, then heart, then recycle. Right, so you might notice that recycle is way bigger on Twitter here. Maybe that's what the peculiar thing is. Let's check it. You correctly completed the task. Next. It didn't tell us, did it? I guess. Oh well. It's difficult to keep track of a large group of numbers at the same time. Therefore, it makes sense to focus on a few rows at a time after sorting a table. Designated fragments of lists are called slices. They're similar to indices, but they're used with ranges of elements instead of single elements. In order to make a slice indicate the beginning and end of a range. So here they have digits name 0, 1, 2, 3, 4, 5, 6, 7. And they want 4 through 7, which give us 4, 5, 6. So you'll notice that it doesn't give you 7. That's like a cutoff. Like that's the that's like a non-inclusive, exclusive. The first index in this example 4 will be included in the slice, and the last in this example 7 will not be. In order to understand why Python developers did this, let's imagine a chocolate bar with numbered segments. Slices 4 through 7 mean that the bar is broken off before the 4th section and before the 7th. When one of the boundaries of the range corresponds to the boundary of the list as a whole, it can be omitted. For example, let's print the first several elements in 2 different ways, indicating the beginning of the list 0 and not indicating it. So you have 0 through 5, and then you have nothing to 5, 0, 1, 2, 3, 4. You can do the same with the very end of the list. As an example, let's print the final 3 elements of the list in 2 ways as well. You see 7 through 10, or they can just do 7 without the 10, and it'll still give you 7, 8, 9. Sorry about that. The video cut out for a second. But let's get back where we're at now. So it says, now let's make a slice so we can print out the first 5 rows of the table. So they give you the same array they had before. And you can see they're getting basically 0 to 5. You don't have to include the 0. And you can see, you can't really see because it's not on one line. So we'll just do the example. They want us to make a slice to get the following items: heart, eyes, kissing, and thinking. So if you look, this is the list here. Let's see what index we need to start at. We need to start at heart eyes, which is 0. 0 would be grinning, 1 would be beaming, 2 would be wrathful, 3 would be tears of joy, 4 would be winking, 5 would be happy, and it looks like 6 is heart eyes. So we can do emoji names 6 to so then 7 is kissing, 8 is thinking, and so we want to put 9 because it's exclusive, And so let's see if we print this here. Let's see what we get. We get heart, eyes, kissing, and thinking, which is exactly what they wanted. But I'm not sure if we're supposed to print it, if we're just supposed to store it in memory, so we can just check it and see what they say. We did it. Okay, so next. Okay, so task 2 here is, let's see. Update the code so that in each of the 3 cases, the output only includes the first 5 rows and not the entire table. Okay, so let's print it at first and see what we're getting. Okay, so they're doing 4-row in data here. And instead we want in data from 0 to the first 5 rows. So you put 5 here. And it's exclusive, so it's going to give you 0, 1, 2, 3. 0, 1, 2. Let's see if you can see my fingers. 0, 1, 2, 3, and 4, which is 5 fingers, right? So even though it's exclusive 5, they did it that way so that it is still grabbing 5 of them because you start at 0. Okay, so hopefully that works. Let's print it and see what we get. Oh, 0, 1, 2. Wait, so this is first row, second row, third row, fourth row, fifth row. Okay, so we got that's the first 5 rows for that one, and then we want the first 5 rows for this one. So we do basically the same thing, and then basically the same thing here. Okay, so let's check that. Correct. Next. Analysis of the results. The recycle emoji has come in at 3rd place according to its populator on Twitter. We have previously mentioned that this is an artifact in our data. We can't sort the table by using Twitter metrics alone because apparently there's an artifact in our data. That means that sorting by another column can be risky too. What if there might be other hidden problems? We're going to need a safer measurement for emoji popularity. We'll develop the measurement, calculate it for every individual emoji, then sort the table by it. We will also need to add another column to the pre-existing table. The time has come to learn how to modify whole tables like lists of lists in a loop. So we say, let's go. Modifying lists and loops. To start, let's learn how to modify simple lists with column values. Let's assume that the values in a list are int and float data types that we want to convert all the values to float. The obvious method, which would be changing variables using a loop, isn't going to work. So they try and cast it here, and afterward you can see the 10 here is still not a float, and the 6 here is not a float. The problem with the example above is how the for loop functions. It copies list elements, so the string element equals float element changes the element variable but will not change the list element itself. Instead of going directly through the list elements, we can utilize their indices. That is, only numbers from 0 to the index of the last list element, not including the last number though. You can do that by calling the range function. We pass it an argument, say 5 for example, and it goes through every number from 0 to its specified argument, excluding the argument itself, 0, 1, 2, 3, 4. These numbers can be printed by placing the resulting range in a for loop. So you have 4 element in range 5, so it's going to go 0, 1, 2, 3, 4 in the range. Unfortunately, you can't simply view the results of the range function. Python doesn't store the numbers from 0 to 5. It can only remember the starting and ending numbers of the sequence. This can be particularly useful when calling functions like range. What is this? A really big number. Now let's try a new method of going through the list elements. Every element in a list has an index. In order to go through all the indices of the emoji express list using the range function, we have to pass it the length of emoji express argument. Okay, so you have range and length of emoji express, print emoji express I. Now we can change each element of the list one by one. Okay, so now they're doing, instead of last time where they just had element here, they're going through the range and they're actually accessing with it with the square bracket, and they're setting it equal to that float. And so after the changes, it does work. You see they're all floats now. And I think that's what they're trying to teach us here. So values from the Emoji Express middle column are stored in Emoji Express list. Change the values in the list so the numbers are written out in their extended form. Instead of abbreviated to millions, for example, 226, 123. So this is 2,260,000. Is that right? As opposed to 2.26. List elements must be int type. Okay, so we're going to do the for loop that we did before. For, let's do index in range. I like to do 0 to the ending, so I would do like length of emoji express. But supposedly you can just put length of emoji express in there. It'll automatically make the first one 0. I just like to be more specific, and it's easier to read that way. So we're going from 0 to the length of the end of the array, and we're going to do emoji express equals emoji I guess we need to do sorry. Emoji express at index equals emoji express at index times 1 million, right? 1, 1, 2, 3, 1, 2, 3. Then we want to cast that to an integer type. Let's make sure I have the right number. 1, 2, 3, 1, 2, 3. Yeah, should be 1 million. Okay, and so we hit play there. It's not actually. I guess we can print it here. I don't know if it wants us to print it or not, but just so we can check our work. Print emoji express. Okay, so you can see they're all integer types now, and they actually have, let's see, 226 with 4 zeros. 226 with 4 zeros. Yep, that looks right. So we'll check it. Correct.